into the Earth via the poles. So it's kind of like a protective mechanism. Basically, the way it works is more radiation means more being redirected into the Earth via the poles. So there's essentially a build-up of particles that cause the Earth's interior to charge. So the Earth needs to vent a lot of this heat that's created from the charge through increased seismic activity and volcanism, but there's not enough release going on at the moment. So one of the things we'll see that they don't talk about is increased amount of seismic and volcanic activity. So basically all living things are balanced with the atmosphere. Changes in atmospheric composition cause life or genetic mutations and, of course, behavioural issues as well and all sorts of things. So we breathe in 20% oxygen as well as nitrogen, argon, CO2, carbon dioxide, which is always the the devil that we're told is bad, and water vapour. Other trace elements in the atmosphere include neon, methane, helium, krypton, hydrogen, ammonia and iodine. So changes in atmospheric composition basically can be out of balance with our bodies and what our bodies are adapted to. So we'll get later into the podcast about how to follow the money trail and understand what's going on and look and see what forces in nature are being most closely monitored. We'll get into that later. So as you can see, there's a lot of events that get reported in the news about freak weather events, funny, light shows in the sky as meteors burn up, all this sort of thing that is becoming increasingly a phenomena, but it's being sort of reported in a disjointed way. The reason is because I don't want you joining the dots. They want you to know, oh yes, the climate's changing, but they don't want you to know why. They want you to believe that it's this devil called CO2 and it's all humans doing it and that the climate has never changed. The reality is that there's plenty of evidence to suggest that the climate has been changing throughout the entire 4 billion years or so of Earth history. We've had ice ages, we've had periods of global warming, global cooling, all sorts of things. There's plenty of evidence in places like the Greenlandic ice cap, if you drill down, as in the deposits that are frozen in the ice cap, as well as in the peat bogs of Ireland, in the growth rings of old trees. All these sorts of things clearly point to the fact that the climate is not stable and has never been. And of course, Earth moving through space means there are going to be different outer space influences on our climate as well. So one event is in October 2017, a space object, I think it's Omawa, I'm not sure if I'm pronouncing that correctly, flew by Earth, and of course at the time there were several near misses around that time. There were at the time changes in space policy, with Trump signing the Space Policy Directive 1 in December 2017 to focus on going back to the moon and going to Mars rather than monitoring asteroids as NASA wanted, which would be a much more pragmatic way of using space resources due to the fact that we are moving through a very dense part of space. But moving on. One of the things to talk about is the composition of our atmosphere. It's really important to understand this if you're going to be able to combat climate change propaganda. They're counting on you not understanding this stuff, so it's really important to get your head around it, including my head, which is not very good with figures, but we're going to have a go. So here we go. So the first layer of the atmosphere is called the troposphere, and this goes from sea level to 10 kilometres. It's at its highest at the equator and lowest at the poles. So the height changes with the season, increasing in height with heat. So in summer, obviously it's hotter. It's going to get hotter as the southern hemisphere warms up as we go into summer. And it's going to obviously be shrinking in the northern hemisphere as the northern hemisphere cools down going into winter. So it's the layer where weather occurs, and the bottom is the warmest. The pressure drops the further up you go from sea level, and it holds the most water and moisture. The next layer up is the tropopause, and one of the things I've worked out is if you've got pause in the name of the layer, it's probably the layer that separates two major layers. It's like a minor layer. It's 12 kilometres up. It's about a 12 kilometre range, so it's not very big. Mean temperature 55 degrees Celsius, and it separates the troposphere from the stratosphere. Next layer up is the stratosphere, commonly known as the ozone layer. So this increases in temperature the higher you go. It goes up another 30 kilometres. The ozone is the oxygen molecule that heats up the stratosphere by absorbing light or UV energy from the sun. More stable air due to less mixing and convection. Commercial flights fly here. Few clouds, very little moisture, very dry. Anything that comes up from the surface, so volcanic gases or any nasties that we humans put in the air, stays here for months at least. The next layer up is the stratopause, which again is a minor layer separating two major layers. It's about 40 kilometers up, separates the stratosphere from the mesosphere. The mesosphere is 50 kilometers up. So the temperature decreases once again the higher you go. Mean temperature minus 90 degrees Celsius. So this layer is very mysterious due to a lack of instruments measuring it. Basically, satellites are up too high. They go past this. Weather balloons and things like that can't reach it. So it's the layer where meteors burn up. And the reason meteors burn up here is because meteors don't need much energy to travel in space. And the heat that is created is because of the friction that's created on impact of air. So the heat can be generated up to 1,500 degrees Celsius. So you can see why meteors burn up, basically. Next layer up is the mesopause, once again a separation layer. And the layer up from that is the thermopause. So these two layers make up the ionosphere. The top of the thermosphere is at about 90 kilometers. So Space Shuttle and International Space Station, or ISS, territory is up here. So air density very low, temperature directly affected by the sun, and varies as it absorbs a lot of X-rays and UV rays when the sun is active. Thermosphere expands to anywhere between 500 and 1,000 kilometers or higher. Thermopause is the next layer up, and that equals the exosphere, which means you're in outer space. It's really important to understand those layers, and I got there. So basically what it boils down to is if there's no matter, there's no heat. It's pretty self-explanatory. So high energy photons hit the thermosphere. They strip away electrons from any gases in the thermosphere, creating charged ions in this layer, creating the ionosphere or aurora. So the magnetosphere is not technically a layer of the atmosphere, but outside it, there's more interaction with charged particles, as this is where any excess charged particles are steered into the Earth via the poles. So if the thermosphere gets seriously charged up by charged particles, it creates heat, and a lot of it at about temperature of 2,200 degrees Celsius, pretty damn hot. So the thermosphere then, of course, becomes something very different. So the atmospheric layers also have tides and waves like the oceans. They keep circulating, going between layers. An interesting little side note, well, don't know if it's a side note. NASA Administrator Jim Bridenstine, I think that's how you pronounce his name, he introduced the Weather Research and Forecasting Innovation Act into Congress. He floated the bill in 2013. It didn't get passed until 2017. And one thing he was quoted as saying when he floated the bill was, quote, "Temperatures quit rising 10 years ago, but here's what I know. My constituents this year will die in a tornado. Let's allocate resources where we can save lives and property today," end quote. So this 10-year timeline was taken from the NASA website, but it's clearly debatable, shall we say. So we are entering into a part of space, as I mentioned before, with a lot of dust, debris, space junk, and it's very radioactive. So as you can imagine, there's a lot of matter hitting the thermosphere and heating up the thermosphere and charging up the ionosphere. So heat coming from both above and below, therefore, because you have the charged ionosphere, the charged thermosphere, as well as the heat from the charged particles as the Earth's crust gets charged and needs to vent through volcanism. So basically, what does this boil down to? It boils down to climate change, folks. Climate change, of course, is blamed entirely on human activity. It's also blamed entirely on CO2. which we'll get into later because, as you can see, it's bogus. Governments are using human-induced climate change in order to justify a lot of really bad things, which we'll get into later in the podcast. But here's the thing. One volcanic eruption can spew out enough gases into the atmosphere to change the climate radically in one day. So that's the thing to remember. So here's the thing. We're told that the Earth is warming up. That's the bit that's actually true. The Earth is warming up. But of course there are plenty of lies around that, which I'll get into in the second part of the podcast. But the reality is that while the element of truth of the Earth warming up is what helps the lie to stick. And this is the thing that's really important to remember, folks. That the way to debunk a lie is not to just outrightly debunk the lie, but to recognise that there are elements of truth in lies that stick, that give the lie credibility. So the trick to debunking the lie is to look for the element of truth and to get your head around Earth's atmosphere 101, space 101, volcanism 101. I'll get into that later in the podcast. So in the next part of the podcast, we will get into the politics of climate change and how they've spun the lie and all this sort of thing. But for now, we're about to have... Uh-oh.
We're going to have the interlude now, aren't we?
Yes, we are, Annie Boatburner.
And we're all going to die! All these soft people who think that the Earth's just going to warm up and kill us all! What do they think?
Well, as I was about to say, the other thing about the climate is it's always changing, and the forces that I've just discussed are forces that have been at work on the Earth to varying degrees for billions of years. So, therefore, it's really important to understand that climate is not stable and climate change is always going to be a thing. Right now, we're just going through a global warming period, but at some point, it could even, in fact, some astrophysicists believe that in the next couple of 100 years, it could swing back to cooling. We could even enter into a mini ice age or even a full ice age. And like I said, volcanoes can change the climate radically in one day, bringing in things like nuclear winters. And so can, by the way, any asteroids that get through the atmospheric belt can also change the climate radically in one day. Thank you, Annie. Thanks for the interruption. We will now have the interlude, can we?
Well, we can if you're going to play some hard rock, but you're always playing soft songs in the interlude, and I'm sick of it.
Yeah, well, this podcast doesn't exist just for you, does it?
I don't care. Just give me some hard rock.
Well, actually, Annie Boatburner, you might be in luck because we're going to have a really interesting interlude today.
Oh, yes. Probably something soft again, is it?
No, actually, it's not. It's Greta Thunberg, believe it or not. She's going to give us the interlude.
Oh my God, she's so soft. Oh my God, she's just so soft. And what's she going to do? Anyway, you just said she's a liar.
Yeah, I did. I did say that she's part of the problem, and I'm going to get into that later. But right now, it's time for the interlude. And we actually do. The interlude is going to be courtesy of Greta Thunberg singing Swedish death metal.
Yes! Look!
Yep, Greta Thunberg singing Swedish death metal. It's awesome, guys. So enjoy, and I will see you on the other side of the interlude.
What's your message to world leaders today?
My message is that we'll be watching you.
This is all wrong. I shouldn't be up here. I should be back in school on the other side of the ocean. Yet, you all can toss young people through. How dare you? You have stolen my dreams, my childhood, with your empty words, and yet, I'm one of the lucky ones. People are suffering. People are dying. Entire